We can switch that over.
Yeah, no, go for the...
Well, this one I can switch off. Let's take the instruments off. So this is this human rhythm composer.
Should we do some drum beats at the beginning?
No, we'd have to connect it all up to do that, you know. We can maybe do it at the end. I feel like it.
Well, we can let this play a bit, because it says that demo song.
We can do it at the end or something.
Yeah.
I'd have to connect it into my speaker system. We'd have to power it up first.
Yeah, too.
So, off. Okay. Get his off and shot, man.
Oh, I'm not in shot.
You will be in a minute.
Yoo-hoo.
You-hoo.
Clean the desk.
Oh, I see.
Oh, that's good.
Oh, I see.
Oh, I see.
C. The C has to be high.
Yeah, this is the
sibilant.
Yeah, the sibilant. Yeah.
See, in English, it's 1, 2, 1, 2.
Yeah.
German must have their own version of this.
1, 2, 1, 2, 2, 3.
But is that what you actually say?
Yeah.
You know, when people test
I'm normally go for 1, 2.
1, 2, 1, 2.
Yeah, this is me going for 1, 2. I always said that.
It's only because I've seen some Spanish artists and bars going, oh, I see, and I don't know.
I have no idea why you do this. This is just testing.
Uno dos.
MC, the mic checker,
Master of ceremonies, I believe.
Yeah, sure.
No, the mic checker. Okay, guys, so...
are we recording?
Oh, we will, actually.
We're recording.
Maybe we won't do that.
Damn it. No, it's more outtakes material.
Yeah, it could be outtakes.
They were great.
Hey, guys, so... Okay. Hi, guys, welcome to Learn Electronics Repair. So to do this, of course, we need a piece of paper. The ubiquitous piece of paper.
Dicky Cat, they call this.
Oh, Dicky Cat, that's the one. Yeah. Not anything to do with the EPOG there. Okay, so my thought was this. If we take a laptop power supply, so this is, as we know, 20 volts or 19 volts plus, okay? And ground. That's what we have on a laptop power supply. And if we feed this into a little circuit, and I'm going to show you the little circuit now, which basically takes a voltage regulator. I don't know what's wrong. No, so let me switch again. Right. And our paper needs to be drawn on. So this is my idea. So the black goes to the ground. The yellow goes to the -10. It's not running at the moment. The red
to switch us off anyway.
Goes to the +10. We have those protection diodes on the circuit anyway, so if we got it back to front, nothing will happen. We switch it on and we power it up and let's see what happens. I hope this doesn't blow up yet. What did happen?
No, not much.
Not much did happen, did it?
You switch it on?
No, switched on. What happened there?
Perfect.
What did happen? Let's have a look. Okay, so
we can skip this part.
We can skip this part, yeah. So this is on ground.
Ooh.
Oh, it's off altogether.
Do we have this the right way around? 20.
20. Well, it can't be the wrong way around. No, it's not the wrong way around. There's your ground.
Ooh. It looks like a diode. 0.2, something Schottky.
Oh. What? There's no voltage going into it. -2.5. +3.
This looks like diodes. Switch it off.
It's cold. It's completely cold.
Okay.
No. Oh!
Oh?
Wire fell off.
Nice one. You scared me there for a moment.
No, there was no voltage there. The wire fell off. There was nothing coming in. But that's the ground back on. Now the black one fell off and took the pad off the bloody thing with it.
Ah, crap.
It's okay. I'll get on there some way. So what it's done is just rip the pad off the end of there. So we can have the black one. To the output of the regulator, which is here. It's on. Yeah, and then we'll test it again, just to see that it's actually working. So, voltage. So this is the ground, black. This is minus 10.
Plus 9.
Plus 9. That's working now, okay. So let's put it back on here again, and this time hopefully it just works. And then we're done with it. Before the thing falls apart again. So ground on here. Okay. Negative on here. Positive on here. Okay. That's all fine. Right,
oh, we're still recording. We're still on. Oh, maybe zoom out a bit.
Yeah, zoom out a bit. Okay. Let's just move this shit out of the way, then we can go on. Yeah. Okay, right. We're on, yeah?
Okay.
Okay, so I've plugged them onto there. Yeah, let's just see what happens. So switch on.
Switch on.
It is on.
The machine is on now.
I'm not. Fuck. What do I have now?
Try again.
Give me the voltmeter.
What the heck?
I don't know. Ground.
I know I had this running.
That says -5 now.
What?
That says 14.
Ooh, switch it off.
What the fuck's going on here? That should just work. What? This is cold. No current was flowing into it. Like, almost cold. What's going on with this? So guys, you can see my solution to this problem. But DETWF wants to do this a different way. So Det, come on, tell us how you'd like to do this and why it's different.
It's a long story.
Okay. It could be a long video.
Yeah, I hope so.
Okay, so let's see. We'll check the main supply rails again since I refitted these capacitors. So we have plus 37, minus 37. Oh. Slipped. Oh fuck. Bastard. Where have you gone? In fact, why don't you start with hi guys, welcome to Electronics with Ben, so me.
This is the right answer.
Well, normally I go hi guys, welcome to Electronics with Ben, and you go hi. So this time, why don't you go hi guys, welcome to Electronics with Ben, and I go.
Okay. 1, 2. Hi guys, welcome to Learn Electronics Repair.
Hi.
I killed this. We need to do this again.
Yeah.
Okay. Hi guys, welcome to.
I need the hi guys with you. That's okay. 1, 2, 3. Hi guys,
and welcome to Learn Electronics Repair.
What's happening here? Is this a reversal of roles?
I don't know. This chef feels like home right now. We're running.
Okay, so we just plug this into the mains. Switch it on. Switch the mains on.
Switch the thing on.
Switch it on. Uppers. Hi guys, well, hi guys. Oh, see. Hi guys, welcome to Learn Electronics Repair. Then we have the large capacitor. Then we have a MOSFET and these two diodes. And I said, what the hell, blippy.
Stat.
Yeah. And by comparison, the ET13S 143 without the macro lens, 160 basically with the macro lens. So the ET14S is a little more expensive, but not greatly so. Let's try it. Oh, stupid thing pop on my screen. So when you switch a switch on, particularly if it's passing a lot of current, if the contact resistance is very low, then the power dissipated, the heat generated in the switch is also very low. If the contact resistance is very low, then the heat generated by current passing through the switch is also very low. The wattage. We'll give it a load, something to switch. We should do. That's why we have the switch. Yeah, to switch. Fuck's sake. Well, a bit hard to see an actual date stamp that I can read, made in Japan. I can see that, okay. Well, a bit hard to see a readable date. Well, it's a bit difficult to see a readable date code, but it says made in Japan. Yeah, about the only useful thing I can get from that. So we have two SCSI drives. But what we don't have, it has what looks like a 24-pin ATX connector down there, and then it has what looks like a 24-pin ATX connector down there, and then a 12-pin one, maybe a 12-volt one. That's the same as this connector by the looks of it. So this is not something I can just power up with what I have available, okay? The cabinet's in a very bad condition, so I think I'll get this board out. Let's get this stuff out. Let's get the short circuit after you've found which one it is. May not actually save you with this one. Also, the CPU could be damaged, but I mean, that's just a plug-in and they're not worth anything, these little. And And these slow ones like this are not worth anything anyway, okay? Ola C. Hi guys, welcome to Learning Electronics Repair. So let's compare that with the datasheet and see if that is good for this type of MOSFET. And here we have the datasheet. And here we have and here we have the datasheet IFPFZHDO. Okay, so we know this is a good one. I've just fitted another one in there. They're from the same batch, so they should be the same, really. Again, switch on. Turn it up until the LED comes on. Just there. 7. Yeah, so 3.5 gate threshold voltage, and then just turn it right up. As mentioned, the 10 amp option is it's optional. As mentioned, the 10 amp option. As I mentioned earlier, the 10 amp option is optional. You don't have to include this, in which case you don't fit the switch and you don't fit these resistors. So, no, sir. As I mentioned, the 10 amp test facility is optional. Okay, are you ready?
No, let's go.
Okay.
Simply go for it.
Okay, right, out a bit, get it into position a bit. Of course it does.
Of course it runs away.
Of course it runs away. It was going to run away, wasn't it? I mean, it would. Okay. Better. The OCD is now some OCD is setting in it. And I don't want us moving while we're talking. Stay. I'm still gonna. That's better. Get that off the edge of the screen. Right. Bitch. now they're in. Right, they're in. ORC. ORC. Guys, I've unsoldered this suspect device, so let's have a look. This is one of the MOSFETs, and it says it's a MOSFET.
Oh, sorry.
So right, I'm just finding the next device to test.
Cool. You're recording already?
I am on record, but I'm just
Okay.
kind of like just clipping the next device to test. That's the real.
Cool.
I'll have a look in a minute then. What you have. Okay, here's the other MOSFET. What does it say about this one? Yeah, that's also fine. And then we are fairly sure, aren't we, guys, that the tip 122 is faulty. Let's see. Peepo, it's okay.
I set this to quiet.
Well, it just said Peepo more quietly.
So no ignoring me. It must be female.
Okay. Oh. And the analyzer says, oh! Okay, so this is the bleepty bleep.
This is important.
No. Okay, so thanks to Det for a few words there.
Yep.
And I will just get on now and show you how to upload this project on PCBWay.com.
You do that.
And then you can just vanish. You disappear. Yeah. You disappear. Yeah. No, right. You do. Yeah. But you do that. I'll go like this, and I'll stay still, and you can disappear, and I'll edit it.
Okay.
Okay.
So, what do you?
So you do that. You say so. You do that and point to me.
Okay. So you do that, man.
No, right. Keep your finger up.
Yeah. Okay. So you do that.
Yep. Right. I'll stay still. Like you. Still recording, it's fine. Okay.
No, you
No, I need to talk. Yeah, we'll do it. Okay, yeah. I know what you need to do now.
Yeah. So, you ready?
Yeah.
So, you do that.
Yep. Let's get to PCB. Wait, right now.